Hello and welcome to this edition of our global webinar series. Today's topic is Advances in Film Technology Show that Miniaturization is not just for ceramics anymore. My name is David Adib, and I am a Senior Technical Marketing Engineer with KEMET here in Florida, and I will moderate the webinar today. We are very pleased that you find the time to join our webinar. Our presenter today is Hristina Kostadinova Boshkova, one of our R&D managers. Hi, Hristina. Thank you for your time today. Please tell us a little bit about yourself before you begin your webinar, and then you can proceed with your presentation. Thank you.
Thank you, David, for that introduction, and thank you, everyone, for joining to this webinar. So, as David said, the title of my presentation today is Advances in Film Technology Shows that Miniaturization is not just for ceramics anymore. So, just to give you a little bit of my background, my name is Hristina Kostadinova Boshkova, and I lead the R&D team in the Balkans at KEMET Film Business Unit. My background is in engineering physics, and currently I'm enrolled in PhD studies in physics. I have spent 14 years in industry, mainly focused on the thin film and process and product development. I've been at KEMET for 9 years in different roles, starting as a process engineer, and in the last years, my role is a research and development manager. So just a little bit of an overview of today's presentation. Today, I'll be presenting the advances that we have achieved in film capacitor technology, all the challenges with which we've been faced during the development of our latest introduced, and also you will see some new miniaturized film capacitor EMI and DC-Link power box designs, which are developed for harsh environmental conditions. Then will be presented their failure mode mechanisms and how we succeeded to withstand them considering the miniaturization and harsh conditions requirements, all the improvements, tests and approvals which have been completed successfully. And all these designs are first to the market, and they will be introduced to you for the first time during the webinar today. So it will be an interesting and excited webinar, and you're welcome to stay with us till the end when we will try to answer all your questions. So if we look at the technology drivers and the focus of the market, we can see that the miniaturization of electronic components and their operation in harsh environmental conditions are growing trends. For example, in order to increase the usage of renewable energies, we would need cleaner power grids and a reliable end-user distribution, and each of those power conversion applications requires hundreds of electronic components that can operate reliably and also in a small space. So also the automotive industry is well known for requiring components that can operate with high reliability at extreme high conditions. On the other hand, the implementation of wide bandgap devices emphasize basically the size miniaturization and increased performance of electronic components. So when components downsize and become more compact, the reliability remains a concern. And in this case, the current EMI and power film capacitors would need capability improvement to meet these requirements. So electronics are a major part of everyday life. And as you know, their usage continues to grow. So many of those devices contain high frequency switching components like transistors, which can generate high frequency electrical noise called EMI, or electromagnetic interference. So because other devices are connected to the same network, they may be affected by DMI that has been induced on the AC mains, and their performance may be degraded. So in addition to EMI, we have a lightning that can occur around the home, and can induce high voltage transient spikes, which can be distributed throughout the home's power network and to damage all those connected devices. So I'm happy to report that KEMET makes a large variety of EMI control components, and I'll focus on the film suppressor technology, but we also have a line of wire and space mount ceramic safety capacitors. So there are two main applications of those. One is the classic, when they are usually used in parallel with the mains. So when the AC line signal comes in, it has noise components associated with. And so in order to get a nice clean signal coming out, we need suppression capacitors in parallel with the mains, and those conduct the high frequency interference either to neutral or to ground. On the mains lines, there are sometimes also lightning strikes, as I said, or other high transients. And these safety capacitors also need to be able to withstand those events and conduct that radiation to neutral or ground. So there are two types of safety capacitors, X and Y. X is connected line to line or line to neutral, and Y is more demanding and is connected line to ground. So then there are other application of safety capacitors in series with the mains, with the main use for voltage control. And here you can see there are various subclasses, and the difference between them is the rated AC voltage position and the peak impulse voltage that they must withstand. So like I said, this is a demanding application. And if the capacitor fails, there could be a shock hazard or even the potential loss of life. As you might imagine that there are very stringent government standards for certifying these capacitors listed on the slide here, where the main one is the IEC 60384-14, which is an international recognized standard that provides strict requirements incorporated in 7 groups of tests, like impulse voltage test, and then we have endurance test combined with impulse, and also other like passive and active flammability, because if there is a failure, you know, the capacitor needs not to catch on fire. Traditionally, a lot of capacitors we use in an indoor and relatively controlled environment. So, but more and more over the past years, there's more demanding outdoors requirement, where the capacitors are used in series with the mains like smart meters or solar and wind inverters, for example. And finally, you know, in automotive under the hood applications, which of course is very tough environment, both from the temperature and humidity standpoint. We have summer, winter, rainy, and also windy conditions. So in more recent years, in addition to the test that I've been talked about in the previous slide, there's been a need to qualify these safety suppression capacitors for what's called THB, or temperature, humidity, and bias testing, where there are grades 1, 2, and 3, and also test conditions A and B with the requirements and acceptance criteria for capacitance, dissipation factor, and insulation resistance, which are defined in the amendment of the IC standard. So for all these severe conditions, combined with the space constraint limitations, KEMET has few EMI suppression safety capacitors solutions which are already present in its portfolio. So in November 2019, KEMET has released a new miniaturized safety design that is a surface mount ceramic capacitor that allows 34% space reduction compared to the radial leaded ceramic disc safety capacitor. And in September this 2020 year, so in 2020, KEMET released the newest miniaturized film suppression X2 capacitor, which advantage is not only the downsizing, but allowing an average of 46% of space reduction compared to the actual F862V054 series, but also this series is qualified and is able to withstand a THB grade 2B, which means 85 degrees, 85 relative humidity at rated 310 VC voltage for 500 hours. So let's go a little bit about the construction of the film capacitor and challenges which we faced during the miniaturization and how we got there. So you know there's considerable amount of material science involved. So just to review briefly, a film capacitor is basically a wound element of metallized polymer film for safety capacitors that is most probably a polypropylene. That's really because it has excellent electrical properties and so appealing capability. So the metallization is usually some type of aluminum zinc that can be flat, heavy edge, wide heavy edge on the slope, which forms the electrodes of the capacitor. Then the capacitor is put in a plastic box for protection, and then this plastic box is filled with some type of potting compound for the mechanically stabilized the component and also to provide environmental protection for the capacitive element. So the capacitor can degrade several ways in a moist environment. There can be present different failure causes like a breakdown or overheating issue if the capacitor is not designed properly. So which are the parameters that can impact on the breakdown? Could be high transient voltage with high energy during the lifetime, high peak voltage repeated several times during the lifetime. Then also the humidity exposed can reduce the breakdown strength and also the self-healing property of the metallized film for the oxidation of the metallization. About overheating, if the ambient temperature the application is over the maximum declared temperature of the capacitor also can cause this overheating issue, and the RMS, if the current is over the maximum undeclared of the capacitor, can cause that the same as metallization of oxidation of metallization in humidity exposure. So the root causes for this failure mode can be due to the reduced self-healing properties, atmospheric corrosion and oxidation, partial discharge or corona effect, and electrochemical corrosion of the metallization. So let's go quickly about these failure mode mechanisms. First one, the self-healing is a property of metallized film dielectrics, and it is the ability to recover from an internal drop of an insulation resistance. So this property ensures safe failure mode in AC frequency application where electrical noise and peak voltages are added repeatedly or occasionally to the fundamental signal. So when the self-healing operates, the temporary breakdown, as you can see here, can occur, which results in a clearing of a small area, causing a minor loss of capacitance and the restoration of the capacitor's initial electrical properties. So as you can see here, polypropylene has the best self-healing properties due to its really good chemical composition that is really visible here compared to the other listed polymers here on the slide. On the other hand, the oxidation of metal electrodes also is mainly caused by the chemical destruction of metals due to the presence of water, oxygen, and other corrosive media. So on the slide are shown the conditions of the two metallized films before and after the oxidation phenomenon. This process is active even without voltage, but its magnitude in encapsulated capacitors is more often negligible, as the reaction rate is limited by diffusion of oxygen into the part and is strongly limited by the compact film winding and thermosetting resin encapsulation. About the partial discharge, inside the film capacitors, there are small air gaps inside the film windings, as you can see here, at which partial discharge may easily occur under high electric field, and it can lead to the electric degradation. So really the film capacitors operating at mains voltage can suffer progressively loss of capacitance as current discharges cause local vaporization of the metallization, and as you can see, the active area is progressively reduced in size that is visible on the film on the side, so with a corresponding capacitance drop. Aluminum or zinc electrodes with an oxide layer on the surface may suffer electrochemical corrosion. So especially when the surface of the oxide layer has defects such as some scratches, cracks, and other impurities, is more likely local corrosion to be induced. So the local corrosion is likely to expose the base metal because the metal is in the active state, and the undamaged oxide layer is in the passive state. So in that case, forming an active passive corrosion battery so that the corrosion can be produced. This phenomenon, the electrochemical corrosion rate of metallized film capacitor, is affected by factors such as operating voltage, operating temperature, ambient humidity, and also the electrode material. So, from a material science perspective, how we do so and how do we prevent these degradations in the new miniaturized designs for harsh environmental conditions? So in general, the film-based material should have good self-healing capability, as I said, but also to show a good behavior under tough humidity conditions. So this means that some film-based materials are not suitable at all for this application. So in our new designs, it was used polypropylene improved for humidity withstanding. The metallization. The resistance selection has an important role in the right compromise between safety aspects and capacitance stability. So for the new designs, it has been used special metallization for humidity withstanding. And there was also a mechanical challenge in manufacturing capacitors with smaller capacitance values. So lower capacitances, require less film and less metallization material, making the product more susceptible to damage due to humidity. So for the new miniaturized designs have been used a special moisture barrier resin and also special box materials. So this slide shows the KEMET roadmap for film safety capacitors and what we are going in terms of temperature, rated voltage, and THB grade for different types of capacitors. You can see the detailed specifications of all these series X1, X2, Y2, Y1 in the datasheet, which are present on our website, but also you can see them in the presentation that will be shared later on after this meeting. So I will know you that recently we released the R52 series, that is the miniaturized X2 capacitor qualified for 310 rated AC maximum operating temperature 110 degrees and qualified as grade 2B for harsh environmental conditions. So in the latest miniaturized film development technology, KEMET really is working and can introduce today a new miniaturized THB X2 film capacitor designed for the most severe environmental conditions, which is 85 degrees, 85 relative humidity, at 310 rated AC voltage for 1000 hours. That is grade 3B, that will be officially launched in Q2 this year, and the name is R53 of this series. So the R52, let's give a quick overview of this series. This is a first to market series design for X2 technology combined with a miniaturized dimension and also high THB grade. And the capacitance range of this series is starting from 100 nanofarad up to 22 microfarad. So this series has the highest capacitance value in the market compared to the other X2 series, that is 22 microfarad, that can fit in pitch 37.5. We can introduce that in the second quarter of this year, we will launch also the lead space of 10 millimeters, where we will expand the capacitance range starting from 47 to 100, also nanofarad in lead space 10 millimeters. Rated voltage is 310 VAC, and the recommended DC voltage for this series is also applicable, that can be up to 630 VDC. Lead space from 10 millimeters up to 37.5. It is fully automotive grade qualified series. The THB grade is grade 2B, and the test conditions 85 degrees, 85 relative humidity for 500 hours at 310 rated voltage. So if we can see the capacitance drift of this series in harsh environment conditions, for the THB test here, we can see the capacitance drift at 85 degrees, 85 relative humidity at 310 VAC for 500 hours. And on the right, we can see the capacitance drift that is really stable at 85 degrees, 85 relative humidity for 240 VAC after 1000 hours. So in terms of volume comparison, so we can see that here there is some comparison between our design of R52 of 1.5 microfarad in pitch 22.5 lead space solution compared to the same capacitance value from our competitors. So if we can see, really there is a very big difference. Here is our design, and so our competitors has increased volume of plus 130, 140%, and also the rated voltage is lower. They declare 305 and we have 310 rated voltage. So really this is a series that is giving a lot of advantages in automotive and all the applications, industrial and energy, where harsh environment conditions are required, and also limitations of the space. This is the new design of X2 technology, miniaturized for the highest grade 3B of THB qualification. So we have the same capacitance value as R52. So the R53 has the capacitance range from 100 nano to 22 microfarad. Rated voltage is 310, recommended VDC is below or equal to 630 VDC. What is also an advantage of this series particularly is that this series is also qualified for THB grade 3B, but not only AC at 310 VAC, but also a DC rated voltage 560 VDC. That is really an advantage. And this is a first series on the market that is able to withstand in both AC and VDC rated voltage from this kind of a design. It is fully automotive grade qualified also, and the lead space is from pitch 15 to pitch 37.5. This series will be available in the next quarter of this year. If we compare the same volume percentage increase of between the R53, that is here our design, with some of our competitors which are present on the market, we can see really a very big advantage. So there are competitors with plus 67, 68%, where the rated voltage is 275, 305, and also other two where we have plus 130, plus 145%. Here also, what is the biggest advantage is also that we can offer 22 microfarad in pitch 37.5. That is the biggest capacitance, and where our competition needs to use pitch 52.5 in order to reach similar capacitance value. So this is a series that has the best harsh environmental performance, and also miniaturized dimension that really can fit in space limited application. Key benefits: we can see the capacitance drift on the AC test condition, so at 85 degrees, 85 relative humidity after 1000 hours. So really the capacitance drop is very stable, minus 1% after 1000 hours. And on the other side, we can see the 85 at 560 VDC rated voltage after 1000 hours, because really it's a very stable capacitance drift. So passing now from AC to DC world, we are talking about the DC-link power box capacitor. So it is an important part of any power conversion module, and its input is usually basically the output of a rectifier stage or a DC-DC stage. And its output is either an AC or a pulse width modulation signal from drive systems, even the input for back boost converters. So the DC-link power box capacitor is used for that intermediate point between the two conversion stages. Its main purpose is to provide a low impedance path for high frequency switching currents, which translates to ripple current. That is a very common associated with the DC-link capacitors, and of course to store the supplied energy when needed. So DC-link capacitors really need to be stable over temperature, frequency, and the time. Here on the slide you can see our DC-link film capacitors portfolio. So the DC-link PowerCAN series, C4D and C44UM. Then we have the DC-link power box, R75H, C4AQ and C4AQM. So you can see the detailed specifications of all this series in the datasheet on the website, and also you can see in the presentation. So today we are announcing the release and the launch of our new miniaturized DC-link power box design, C4AU. That is first to the market series that has miniaturized dimensions and also is able to work in the harshest environmental conditions, that is 85 degrees, 85 relative humidity at rated VDC voltage for 1000 hours. So this series will be available on the market in the first quarter of 2021. So let's briefly introduce this series. C4AU has a wide range of capacitance value starting from 1 to 210 microfarad with a rated voltage range of from 500 to 1200. It's fully automotive, ACQ 200 qualified, and this DC-link design has high capacitance density, low leakage current, low losses, excellent self-healing capability, long operational life, and it's really able to withstand high power and high ripple current, a large amount of charge-discharge cycles, and it's able to operate reliably, safely, and harsh environments. So here are some key advances of C4AU, the miniaturization or space optimization. So to give you an idea versus the C4AQ, the downsizing of C4AU results with 23% reduction in volume versus C4AQ, 29% in PCB surface area. That is a reduction of lead space for certain capacitance values. Related to the harsh environment capabilities, we are very proud that this series, C4AU, has the best harsh environment capability, and it's fully qualified for the highest grade of THP applications, that is 85 degrees, 85 relative humidity for 1000 hours at a rated voltage with drop of capacitance less than 10%. So C4AU has high peak current capability, that is for 150, 200 and even 400% higher compared to actual C4AQ. So these advances brings some advantages of C4AU. So the miniaturization allows less capacitors in parallel to meet the required peak and ripple current, and the replacement of an electrolytic capacitor solution. Basically, and the miniaturization and the high peak current capability allow extended life of the DC-link and the fast wideband gap devices, switching frequencies, and also current. So as you can see, this series also has high ripple current capability with self-heating up to delta T of 30 degrees until 70 degrees Celsius. That is for 15 degrees higher than the C4AQ. So in this case, the current capability is optimized up to 70 and even after 70 till 125, which means that C4AU is also capable to meet the automotive high operational temperature up to 125 degrees for short full power conditions. So here we can see that extended life expectancy up to 200,000 hours with voltage derating is present, and we have 100,000 hours at hotspot of 70 degrees, then 200 hours that is really harsh environment at 125 degrees hotspot. So C4AU is the smallest DC-link box design for the most severe harsh environments for applications with small limited space on the PCB, since the design has the best temperature, humidity, and bias performance at 85 degrees, 85 relative humidity at rated voltage for 1000 hours, where also a high ripple current and high peak current capability is required. And on the other hand, its low ESL is making suitable for frequencies close to ones of the wide bandgap semiconductor applications. So here is the timeline of the release for this series. As I mentioned, R52 is the series that also has been released. It's been launched in mass production, and in this quarter, C4AU will be launched. So we will have this miniaturized series. In the second quarter, we will launch the R52 pitch 10, so the lead space of 10 millimeters, with the expansion of the actual design of R52, meeting the same THB performance and also CQ200 qualification, and R53, our miniaturized X2 capacitor with the highest grade 3B for harsh environmental conditions, and also VDC application rated voltage. So thank you very much for your attention. If you have any questions, you can send to my email, or you can see here on my slide.
Thank you, Hristina, for this presentation. Let's see if we have any questions that we have received. I'll give it here a minute for questions to make their way through. Okay, ladies and gentlemen, thank you once again for joining us today. We hope to see you next time. Until then, we wish you the best. Goodbye and have a good day. Thank you, Hristina, once again. See you next time.
Thank you very much.
Thank you. Bye-bye.
Thank you. Bye-bye.